Hello everyone, my name is Danish and I am doing masters from IIT Hyderabad. Today I am going to discuss one of the important topics of class 11th mathematics that is known as complex numbers. So let us start this. Since you may have seen this equation x square plus 1 equal to 0 in the real numbers, and that is x square equal to minus 1, that is x is equal to plus minus under root of minus 1. So you may know that this type of equation does not have any solution in real numbers, because there is no real number whose square is equal to the minus 1. So to solve these type of equations, we introduced a new type that is known as imaginary numbers. Imaginary numbers. So in imagine, what is the imaginary number? That is iota. Iota is equal to the under root of minus 1. So similarly, iota square is equal to the minus 1. So now define the complex number. What is complex number? What is complex number? So complex number, any number uh, which is of the form z equal to a plus iota b. That number is called as complex number, where a is the real part and b is imaginary and iota is equal to the under root of minus 1. So any number which is of this form, a plus iota b, we call that number of a number as a complex number. Now second, we will see that what is a conjugate of a complex number. That is, we write this as if we have a complex number z equal to a plus iota b, we write its conjugate as z conjugate equal to a plus iota b, that is equal to a minus iota b. So we write this as a conjugate. Now coming to after this, now we will see what are the basic algebraic operations in complex number. Algebraic operations in complex number. First, we will take let z1 is equal to a1 plus iota a plus iota b and z2 equal to c plus iota d, where a comma b comma c comma d belongs to R. That is, these are all real numbers and iota is equal to under root of minus 1. Now we will define first operation, that is addition operation. That is z1 plus z2 is equal to the a plus iota b plus c plus iota d. So what we do, this real part is added with real and imaginary is imaginary. That is a plus c plus iota times b plus d. Similarly, second type of operation, that is subtraction. So in this case, z1 minus z2 is equal to a plus iota b minus times c minus iota d. Similarly, here in this case also we take real on the we subtract real with real and imaginary with imaginary, that is iota times b minus d. Now that another operation, that is multiplication. What we do in this, we have z1 into z2 is equal to the a plus iota b into c plus iota d, that is equal to the AC plus iota times AD plus iota times BC plus iota square times CD, that is equal to the AC, sorry, this is BD. AC, we know iota square is equal to -1, so we write this AC minus BD plus iota times AD plus BC. So now here are some first we now see the division operation. That is Z1 upon Z2, that is equal to A plus iota B upon C plus iota D. In this case, we try to multiply the denominator by its conjugate, that is C minus iota D upon C minus iota D, that is equal to, now it will, since we know A plus iota B into C minus iota D is equal to A into, that is AC minus iota times AD minus iota times BC this BC minus iota times BD upon, and this will become C square plus iota D square. This will become the identity A plus B into A minus B, that is equal to the AC, this is iota square. Iota square is equal to -1, that is minus into minus, that is plus AC plus BD minus iota times AD plus BC upon C square minus D square. This is the division operator. Now one of the also the important concept, that is Argand plane, or we see that as complex plane. Like in real numbers, we have a real plane, that is xy plane. Here we have an Argand plane or complex plane. That is, if it says that any complex plane, any complex number z equal to A plus iota B can be uniquely represented by a unique point, P of A comma B in Argand plane. That is and this, if I have so this may not be straight. If I have this plane where this is a real of Z and this is imaginary of Z point, and consider this point P of A comma B, which has a distance of A from this and distance of B from this. So P of A comma B, and that is P of A comma B represents complex number that equal to A plus iota B. Similarly, we can see the modulus. It is a modulus of a complex number. Modulus of a complex number. That is, if I have a complex number, consider that is z is equal to A plus iota B, then the distance of z distance of z from origin, and z equals to then the distance of z from origin, that is, if I have origin and this is z, is known as modulus of a complex number, and it is represented as, and it is written as mod z is equal to under root of a square plus b square. So this is all for today's lecture. I hope you understand this, and thank you. Bye bye. Have a good day.